got the proof by contradiction question. So we're given absolute certainty that PQ is even. Now we're asked to prove that at least one of P or Q is even. So we're actually going to assume the opposite. Assume P and Q are both not even. And we're going to try and seek a contradiction. So therefore, P and Q are going to be odd, because they're either odd or even. We know that they're definitely integers. So let's let P equal 2n plus 1. That's the way we can write down an odd number. We could say that n is going to belong to the set of integers, or I mean, you don't have to write that, but it is good practice to do that. And then Q is going to be 2m plus 1. Use a different unknown here. Don't start writing 2n plus 3, because they would be consecutive. We're trying to show that n and m could be anything, actually. So m would also be an integer. Right, let's multiply them together. PQ is then 2n plus 1 times 2m plus 1. We're going to try and show that this cannot be even. So it's going to be 2n times 2m, that's 4nm, plus 2n plus 2m plus 1. You can factorize the 2 out of the first three terms. And this is another odd number, because it's a multiple of 2 plus 1. And that's a contradiction. Therefore, we can say at least one of P and Q must be even. Let's take a look at part B. So we're given that x is negative and x plus y squared is less than 9x squared plus y squared. Show that y is greater than 4x. Let's start with the bottom statement. So this implies we can expand the bracket that x squared plus y squared plus 2xy is less than 9x squared plus y squared. Can cancel out the y squareds. That means that 8x squared is going to be greater than 2xy. I'll divide through by 2. 4x squared is greater than xy. And now I'm going to divide through by x. And I'm just going to say dividing by x will swap the sign around since it's negative. And therefore, 4x is going to be less than y, or y is greater than 4x. Thus, our proof is complete.